pretend like when the video starts that I'm talking about Michael O'Connor because I really just don't like that kid. Dang, I got that on video. Okay, so I'm waiting on you. Well, which one is an interior function, guys? Cosine. Yeah, now, you could work this two different ways. You can, right now, just recognize that you got cosine cubed here, cosine squared here. You don't have a cosine here, but that's okay. Because all of this is multiplied by sine, yeah? So if I let you be, also, this is really pretty glitter, isn't it? You're welcome. You're welcome for the bling. Okay. So I could distribute sine to each of these, and then this term right here would not require u substitution. But as is, if we go ahead and let u be cosine, then what's du? Yeah, negative sine t dt. All right, so I have a sine t dt. I don't have a negative, so what are we going to do? So negative the integral of what? Yep, 5u cubed plus 2u squared minus 10 d what? Du. So what's the antiderivative of 5u cubed? 5 fourths u to the fourth. Plus what? Plus what? 10u. So that's where you got to be careful. Because it's antideriving with respect to u, right? What is u? No, really annoying. That's what u is. No, I'm just kidding. So that joke never gets old. Okay, so cosine to the fourth minus 2/3 cosine cubed plus 10 cosine plus c. So what if we had distributed? Your integral would have looked like this. 5 cosine cubed t sine of t dt. Yeah? And I'm going to go ahead and split up the integral and do each of them. Plus the integral of 2 cosine squared t sine t dt. Yeah? Minus the integral of 10 sine t dt. So do you see how, guys, both this one and this one would require u substitution, but then this one would not? What's the antiderivative of 10 sine? Negative 10 cosine, right? But it's already a negative, so it becomes plus 10. So that's why you would have to tack on that u, not just t up there. Okay? All right, y'all good? All right, if there are no other questions, then we shall move on to 5.7.
Wait, what? 5.7?
Yeah.
Oh, I skip it, I guess. I'll have it in there. I think it's something we've already done, in essence. Look at that. What's 5.6 say? You, with the book open. For those of you on video, I'm talking to Daniel, in case you're wondering. Yeah.
Numerical integration.
Yeah, we're good. Okay. So, y'all ready? You good? You prepared? Logarithms and antidifferentiation. One would assume that this lesson is going to be about logarithms. Yes? That is a hint. Hint, hint. Okay. Okay. You know, I can't move the box on my paper. It's kind of difficult. Thankfully, I just have it pulled up on my computer, too.
I mean, you can cut it out, maybe.
Yeah, and then it's a window. Okay, all right, guys. So, how do you antiderive 1 over 2x? Okay, if you let u be 2x, not with that pen. What's du? 2dx, what do you put in the front then? 1/2 the integral of 1 over u du. What's the antiderivative of 1 over u? Yeah, so 1/2 natural log of the absolute value of u plus c, and what's u? Interesting. Because couldn't I just split this up and say 1/2 the integral of 1 over x dx?
Yeah.
They probably think I just froze. Okay, because that's just 1/2 natural log of the absolute value of x. So what's up? Help me figure this out. Because I wasn't thinking doing this, but since you said it, I want to go ahead and do it. 2 That's just a constant, but it absorbs into it. Yeah, it's going to be equivalent. I don't worry about it. Okay. Wait, why do I have 2 2's?
Don't worry about that part.
This part would just absorb into the c, yeah?
Oh, yeah.
Because that's just a constant. So, okay. I was just like, wait, they're supposed to be the same answer. And they are-ish.
C is just different.
Yeah.
C is just different.
I mean, it's just absorbing in the constant. So, yeah, okay. All right. I'm no longer upset about it. This is how I would work it. I would just take the constant out. But this is not wrong. I mean, it's not wrong, right? No, that's C. It's 1/2 natural log of 2 plus 1/2 natural log of x. Sorry, that needs to still be absolute value of x plus c. This constant, sorry, you couldn't even see what I was writing. That constant can absorb that. This is just, yeah.
A constant is a constant. I even like it.
Oh, when you have logarithms and there's multiplication, you can split them up using addition.
But what about the fact that it's not?
It's okay. As long, I kept the absolute value on the x. See, it's a... Yes, and it's eating it. Okay, and so, now I want you to enter to derive this one. Does this require u substitution?
No, I mean, yeah. I mean,
Can you split up this fraction?
That's what I think.
No, you can't. You can't split up the fraction.
Yeah.
If the derivative of, so if it's 1 over x, it doesn't require, but it's 1 over 4 minus x. If it was 4 plus x, it doesn't require u substitution, because what's the derivative of 4 plus x? 1. What's the derivative of 4 minus x, though? -1, which means it requires u substitution. So even if you get to the point where you're doing it in your head, it still requires it. So u is 4 minus x, what's du? -1 dx. Do we have a -1? So we put negative the integral of 1 over u du. So what's the antiderivative? Of 4 minus x. Good. U is just that, so then plus c. Okay? All right, let's go to this one. So if you were not here on Friday, did you see how we approached doing problems like this? Did you notice where we changed limits of integration? Noah, did you see that? No? Noah, did you fail to copy down the notes?
Yep.
For everyone on video, Noah Smith is a terrible student.
He is.
And he
Get
probably
used
has
to
no
the
idea
one-
what's going on. No, what's that?
Usually you just change the limits to be in terms of you and x.
Right, and so like you don't have to, but what it allows you to do is it kind of it does when you evaluate, you know, f of b minus f of a, you already plugged it into the function, so you've already done half the evaluation. It kind of keeps things from getting really messy towards the end. So Noah, you'll see. Okay. All right, guys. Do you see a function and its derivative? I do. What's u?
You-
X squared plus 1. What's du? We have an x dx. We don't have a 2, so what do we put? 1/2 the integral. Now I'm gonna work this both ways, okay? Okay, if I don't change my limits of integration, what do I write right here? So I don't put any limits of integration. I just put what? 1 over u du. Are y'all with me? Is everyone with me? So x dx was replaced with 1/2 du. This is replaced with u. Are y'all with me?
Yes.
So that's 1/2 du. That's 1 over u. And then we're not putting anything there. What's the antiderivative of 1 over u? Mm-hmm. So natural log of the absolute value of u from nothing to nothing, right? But what do? I go back to u being what? Hey guys, in this case, are these absolute value bars necessary? X squared plus 1 is never going to be negative, so I don't need to worry about them. So from 0 to 3. So what do I suggest you do with that 1/2 out in the front, guys? Just leave it out, right? So what do you plug in first? 3 squared plus 1? 10 minus, plug in 0, you get 1. And what's natural log of 1? 0, final answer. 1/2 natural log of 10. Okay, so let's review. If I change my limits of integration, I do half of that substitution from the get-go, yeah? Do you guys remember, like, what do I plug in first? Yeah, the upper limit and the lower limit, just to keep them in order. So you plug the limits of integration into what u is. So basically you're doing this part where you plug in 3 into x squared plus 1, you plug in 0. You're doing this ahead of time. So what's 3 squared plus 1? 10, and 0 squared plus 1 is 1. So we're going from 1 to 10 of 1 over u du. Yeah? So 1/2, what's the antiderivative of 1 over u? The absolute value from? Okay. So you see how this is a little bit cleaner? I'm especially talking to you two.
Yes.
Okay. So it's 1/2, not, oop, just kidding. Ah! Oh, sorry. No, it's fine. Sorry, my computer was being weird and it didn't matter to you guys because you couldn't see it. Natural log of 10 minus natural log of 1, which is 0, and there you go. So I like this a whole lot more because you're not having to plug into this expression within another function at the same time because they can get pretty ugly. Hey, what's another way to write this answer, guys? Yep. Did y'all recognize it?
Nope.
You're fired.
All right. You can use the thing. Oh, we're not.
All right, 1 over x ln x. Guys, they're only going to get more fun, which is exciting. Okay. Do you see a function and its derivative?
Yeah. Yeah.
1 over x.
1 over x and then
Yeah, what's the derivative of natural log of x?
1 over
Exactly. So in this case, this is one of those times where the 1 over x, even though it's in the denominator, the x is part of it. So just for giggles, you can, like you see that can be rewritten as that, right? Okay. So if u is natural log of x, what's du?
du.
1 over x dx.
Over x.
So 1 over x dx is du, and that is 1 over u. And so what is it? Natural log of the absolute value of u, and what's u? Yeah, natural log of the absolute value of natural log of x. Bless you.
That's beautiful.
I think it's cute. Okay. We're going to do this problem, and we're going to do two different ways. One of the ways we're going to do it is just because the certain way it works out, but I'm going to show you the other way that works every time. So you got the integral of x squared plus 6x plus 3 all over x plus 3 dx. So the way we've been learning this, the idea has always been find u and then find du, right?
Yeah.
If you were approaching it this way, what would you let u be? Right, because it's the higher power term, right? What's the derivative of x squared plus 6x plus 3?
2x plus 6.
If you factor out a 2, you've got x plus 3, but can we have du in the denominator? No. That's called weird. You don't integrate with respect to 1 over dx. That's not a thing. Okay, merely because 3 happens to be half of 6, I'm going to show you this method, okay? I'm going to go ahead and start doing it, and then you see what, I want you to see how quickly you can catch on. What am I doing? So I moved the 3 over, and I said, okay, if I cut 6 in half, I get 3. So if I can make this the perfect square, x plus 3 squared, if I add 9, I've got to also subtract 9, right? And so I can rewrite this as this binomial. So merely because this is 6 and this is 3, I can do this because what can I do now with this fraction? I want to split it up and then cancel things, right? So it's the integral of x plus 3 squared over x plus 3 dx minus 6 times the integral of 1 over x plus 3. I like to take the constants out if possible. So I could have said 6 on top of this, but I might as well bring it out. Are y'all with me on that? Okay. Now this one I can cancel one out. So what am I left with? And what's the antiderivative of x plus 3? Plus 3x. What's the antiderivative of negative 6 times the integral of 1 over x plus 3? What's that? Well, okay, so technically it's a u, but is there a du? What's the derivative of x plus 3? 1? So you can treat x plus 3 as if it was just x, right? So what's the antiderivative of 1 over x? Natural log of the absolute value of x. So what's the antiderivative of 1 over x plus 3? And there you go. That's it. Now, completing the square, guys, is going to be a method that we use later on in calculus as well. But the next one is one that we're definitely, like, you're going to see. Completing the square was useful here just because there was half. But the next method is something we're going to carry with us for sure. Okay? So, if you don't have a UDU, but you're dividing by a binomial, why don't you just go ahead and divide? You know what I mean? Like literally divide the polynomial. You can do long division or you can do synthetic division. What do you want to do? So what goes in the half box? -3. What goes across?
1, 6, 3.
Bring down the 1. What's that? Do you see how this divided by this is x plus 3 minus the remainder divided by what you divided by? And isn't that what we just derived? So synthetic division is one of those. If you're dividing by a binomial, go ahead and divide it. Yeah. That's called exciting. I'm glad you guys are so happy about it. All right, so let's do it. Hey guys, is this a binomial in the denominator? Yes, but is it linear? No. It's a quadratic. Does it factor? Technically, yes. I and negative I, right? I say right because you all right there with me, right? I mean, sum of perfect squares, imaginary, difference, obviously real. I could do synthetic division. We're not going to. Why would I do synthetic division with 2 imaginary when I can just do long division, and long division's easy, right? Say right.
Right.
Okay. Isn't it cool that you have to remember everything you ever learned in math? So, at least maybe you feel, maybe you don't resent me for teaching it to you in Algebra 2 as much because, like, turns out you did actually need it. What's up? Ah! Sorry, my page jumped. Yeah. Okay, what do I do? Yeah, exactly. It's like, what do you need to multiply x squared by to get x squared? And that's 1. Yeah? So what's 1 times x squared plus 1, guys? Now what do I do? Do you guys remember long division? Oh my gosh.
Not this long.
It's been 2 years.
You didn't do it in pre-cal?
No.
I was about to say bullcrap.
Oh, wait, no, we didn't.
Nah.
We did not do it.
No, I don't remember doing it in pre-cal.
Last time I did this, it was on my laptop.
Oh, she started a whole new
I'm just reminding you. You don't have to do it. Just watch. What are you going to multiply 2x by to get 4x cubed? So then you multiply 2x squared times both of those. What do you get? And then what do you do? And what are you left with? Bring down 5x. What do you multiply 2x by to get negative 8x squared? Negative 4x. What's negative 4x times 2x? Negative 8x squared minus 4x. What do you do? And you're left with?
Because you subtract this.
This was negative 4x times 1, right? Now we change the sign. What do you get? 9x plus 10. Now, I know that 2 times something giving you 9 is very difficult, but we are in calculus.
I know for two.
We shall put, oh my gosh, good job. Those of you in the video, that was Tadagat. Tadagat is the winner, the most advanced student in this room. Okay, 9 halves times 2 is plus, let's go 4.5. I like decimals sometimes, maybe. Subtract, what are you left with? That was bad. I was almost fired. Okay, so it's just like this plus 5.5 divided by what you divided by. Yeah? If we had done long division or synthetic division with what? 4, negative 6, 5, 10. Yeah? Ah, wait, why do I have an 8? Why do I have a 4? Why do I have an 8? Oh, why do I? Oh. When you divide by a fraction with synthetic division, you got to divide by 2. Ha, whoo, 2. Negative 4. Y'all not know that? Hey, okay, so think about it like this, guys. I'm trying to get this function, yes?
Yes.
Okay, what I just found was that when I divided out 2x plus 1, I got 4x squared minus 8x plus 9 plus 5.5 divided by 2x minus 1. Does that make sense?
Yeah.
No. Because that times that would give me 8x squared, right? Synthetic division will never lose that leading coefficient. Do you guys see how I just divided out like 2x plus 1, the factor, you can't see. I just factored out 2x plus 1, which means this right here, I've already taken out one of the factors of 2, so I can only have one other polynomial with a leading coefficient of 2. This is saying it's 2x plus 1 times a 4x squared, right?
I don't know what you're talking about.
Okay. How about this?
I'm sorry.
No, it's okay. Multiply it out. What do you get, guys? 2x squared minus 7x minus 4. Okay, so guys, if I do synthetic division with negative 1/2, 2, negative 7, negative 4, I should be dividing out this term, which means my leading coefficient. My answer should be 1, but this will never go away. Synthetic division just drops it. 2, negative 1, negative 8, negative or positive 4, 0, right? So it's telling me that when I divide this quadratic by 2x plus 1, I get 2x minus 8, which means these two multiply by each other, right? But that's not that.
Why doesn't it work?
Well, that's the thing. If you divide by a fraction using synthetic division, whatever this is, you have to divide by that too. Oop, just kidding, that one. So it is x minus 4.
Didn't we already use the negative 1/2 though?
I'm just saying it's a problem that synthetic division has. I divided out the leading coefficient of 2, right? The term that has leading coefficient, but with synthetic division, when you divide by the negative 1/2, it goes away, right? Or it doesn't go away. It never does. This 2 is always dropped, right? If you were to do long division, it would work out just fine. 2x plus 1 into 2x squared minus 7x minus 4. What do you got to multiply 2x squared by to get, or 2x to get 2x squared? Just x. So you see how here it's not an issue. It's just, wait, why do I have a 6 all of a sudden? Oh, it was plus, now it's minus. Thank you. So it's just an issue that that synthetic division has. Don't worry about it. Okay, I'm done. Okay.
Do we have to know that?
It's usually not a fraction. It's usually just a whole number. All right, guys. Hey, we got to keep going. What do we do? You subtract, what are you left with?
No.
Okay, as soon as this is, this is as soon as it's a lower degree than what you're dividing by, then that is your remainder. So my function is 1 plus the remainder divided by, exactly. This is the same thing as that. Okay, well, so let's talk about it. Because if I tried to let u be, well, what would you let u be here? And what's du? Now, you have x squared up here as well, right? They're the same power. You need a power and a power lower if it's polynomial. You know what I mean? Neither one of these is the derivative of the other. That's the issue.
Oh, I
But-
was talking about over here.
Oh, yeah, I know. That's what I'm saying. Like, it doesn't work here, but this one right here, what's the antiderivative of 1? X. Now, this one, I now have a u and a du. What's u? And what's du? Do we have a 2x dx? So 1/2 the integral of 1 over u du, which is? Do I even need the opposite value bars? No. Okay, guys, so what I need you to get from this is that if you're doing a problem and they're the same power on top and bottom, or it's polynomial and you can't like separate them, a u and a du, go ahead and do the division, be it long division or synthetic division, okay? You can do synthetic division if it's a binomial with a power of 1. If it's anything higher than a power of 1, you got to do long division, okay? All right, let's do this one. There's a big hint there. Do you see it?
It's a star.
No, that's a star to indicate that there's a big hint. I know. I'll write it for you. So, did you write down the integral of secant? Do you know why we need a hint? Do you know a function whose derivative is secant? It'd be pretty impressive if you did, because it's an ugly one. Okay. So, I'm going to write this down, and you're going to be like, of course, duh, I would think to do that. Yeah, I mean, I know that's what y'all were thinking. Well, yeah, that's why we can do it, but what does it allow me to do?
Is it a stagger? Somehow?
Secant squared, secant tan.
Well, I don't know yet if you know what we're doing, but I can't split up the fraction like top versus bottom. What are you trying to say? Or what are you pointing at?
Oh, I just realized
The top one's not you. The bottom one is. Why is the bottom one you guys?
Numbers.
Write it down. U equals secant x plus tangent x. What's du? The derivative secant is secant tan. What's the derivative tangent? And there you go. The numerator is du. Okay, so obviously I'm showing you this because I would never in a million years expect you to come up with it, right? But once you've seen it, you have to be able to reference it. So this is one that we might write down on our purple sheet at some point. Guys, can you also extrapolate that if this was the integral of cosecant, you would do something similar?
Yes.
Okay, I would expect you to play around with it and figure out what it would be. But it's probably going to be some cosecant and cotangents, be they positive or negative. You'd have to figure it out, okay? Okay?
How do you know what to multiply by? It's equal to 1. How do you?
Well, that's what I'm saying. If this is secant and this is secant plus tangent, well, cosecant has the same relationship with cotangent as secant does with tangent.
And how do you know whether they're positive or negative?
Play around with it.
And just figure out what goes through the integral.
But, well, yeah, so if you did cosecant plus cotangent, would it work? If you did cosecant minus cotangent, would it work? You did negative cosecant minus just see. I'm not just going to show you.
Okay.
So guys, what am I anti-deriving?
1 over u.
And what is the antiderivative of 1 over u? And there you go. That is the antiderivative of secant. I know. I'm hoping you're starting to realize that I mean it when I say integrals are much uglier than... They're ruder. They're much ruder than derivatives. Yes? Not yes that they're much ruder, but yes that we're good. Okay, we good? Okay.
No.
I feel like you just saw a bug or something, but no, it's a calculus problem. Okay, the integral from 0 to pi over 4 of the square root of 1 plus tangent squared x dx. What?
Tree identity.
Hey, remember you can develop it right quick. Guys, how do you find tangent?
And its sine.
So we divide everything by cosine squared. What are you left with? Tangent squared plus 1 equals secant squared. So, guys, what is 1 plus tangent squared? Why is that nice?
Because then you can get tangent after.
Because it's just
But it's not secant squared.
Oh, yeah.
just C.
Oh.
It's just secant.
Wouldn't it have to be plus and minus?
No. That's if you're taking the square root. Square root's already there. It's already implied that it's just the positive. Hey guys, what's antiderivative of secant? Exactly! That easy thing that we just memorized.
We have to have that memorized.
Do you have to have that memorized? Not for my personal test, but I don't remember if that's something that on the AP exam they require. I don't think so. I don't think that they'll ask you about that.
The integral of secant is the natural log of the absolute value of secant.
That's gonna be the very first question on the test.
Hey!
The integral of
Hey guys. Pi over 4 is right there in the middle, right? Hey, goodbye. Take a picture.
We're at the wait until Michael gets
everyone look for Michael to take pictures.
Oh.